In this question we're going to solve a differential equation. It's an exam 1 style question, a by hand kind of question, but I do show you at the end how to do this on the CAS if you have a TI CAS handheld device, which is what we use at my school, just for a little bonus for you. And if you have a Casio, I'm sure there's something very nifty you can do on that too, but I just don't know anything about the Casio, sorry about that. Alright, solve the differential equation dy dx equals x times the square root of x squared plus 16, given that y equals 5 over 3 when x equals 3. Well, it looks a bit daunting at first glance, guys, but really, when you think about it, they call it a differential equation, but all we've got to do is just integrate that right-hand side of that equation, and we've got it, and it's a pretty standard looking integral. So what you've got to do is develop a basket of techniques, like a checklist of, is it this, is it that, is it something else, what is it? And one of the very first things you ask is there an original function plus its derivative? Are they both present in the integrand? Well, we've got here y equals this, okay, the integral, and of course, yes, you do have an original function and the derivative both present in the integrand. So my question to you guys is, what is the original function and what is the derivative? Well, guys, the original function in my book is x squared plus 16, because that has a derivative of 2x. And I know that's only x, but we can very easily manipulate that so that it is a 2x and then put a half out here to compensate for what we're doing, and we're laughing, guys. So you let u equal x squared plus 16, therefore du dx is 2x, and therefore du is 2x dx. Now, this is the way I do these. I then say we have, what do we have? We have a half of this little beastie times 2x dx, and I'm lining up the 2x with the dx because that is exactly equal to du. And now I'm going to do the old switcheroony with the du, with the u's in there instead of the x's. Okay, do you see that? Okay, now it's very simple to integrate that now. As you can see, that's just u to the half, which will be, what will it be? 2/3 of u to the 3 over 2 and plus c. Don't forget the c, guys. So let's just simplify that a little bit. The 2's cancel, and we've got 1/3 of u to the 3 over 2 plus c. Let's now substitute back for what u was, because we're kind of out of integration danger. There it is. And we're going to substitute our initial conditions in here. We're substituting x was 3 and y was 5 over 3, and let's see where that takes us. So 5 over 3 is 1/3 of 3 squared plus 16 to the 3 over 2 plus c. Now that looks like 3 squared is 9, and 9 and 16 are 25. Good, good. 25 to the 3 over 2. Okay, well that's going to be 5 cubed, which is going to be 125. So 5 over 3 equals 125 over 3 plus c, and therefore c is going to be minus 120 over 3, which is minus 40. Yep, isn't that great? So therefore we've got our answer. Y is 1/3 of x squared plus 16 to the 3 over 2 minus 40. Guys, no problem. But you do need to get your checklist of integration techniques available, and you need to get very good at recognizing which one each individual case is and falls under before you start rushing in trying to do them. Okay, if you want to do it with CAS, with the TI handheld, it's very easy. Over the screen, there it is. You just look for the calculus menu, and the syntax is solve y dashed, that's dy dx, equals this thing, and then you put your initial condition, if you have one, like that, and y at x is 3 is 5 over 3, then you put comma, independent variable, which is x, and then a comma, and then the dependent variable, which is y. It's always comma x, comma y, guys, like that. Yeah? And you get your answer. There it is. Sweet. Alright, I hope you got something out of that, and we'll see you soon.